Jeff, welcome to Talk Python to me.
Thank you for having me.
It's great to have you here. We're going to talk maps and consuming map data and a lot of interesting research that you've done with that data. So you have a very cool project, OSMNX, OpenStreetMap Network X, that we're going to dive into. And it really makes all of this street and map data super accessible to users of Python, right?
Yeah.
Yeah, excellent. I'm really looking forward to talking about that. Before we dive into it, though, just a quick introduction. Who are you?
Yeah, so my name is Jeff Bowen. I'm an assistant professor at the University of Southern California here in Los Angeles. I'm in its Department of Urban Planning and Spatial Analysis. And most of my research and teaching are around that intersection of urban planning and spatial analysis. I did my PhD in city planning at UC Berkeley, and my focus is on urban data science. So using Python tools, usually open data, to try to understand cities and housing markets and transportation networks and how people move through space and how we can make our cities more resilient to natural disasters, which is relevant in LA this week. Also more equitable, nicer places to walk around, and basically just better for urban living.
Okay, well, that sounds like amazing research. It's probably interesting to live in LA as one of the bigger, crazier locations in terms of sort of traffic and congestion and population. It's not New York in terms of density, but it's probably its own special beast, I imagine.
Yeah, it is. LA is an ironic place to be an urban planning professor because it can be so frustrating for a lot of our best practices in urban planning. But at the same time, there is no better place in the US to be studying and trying to intervene into some of these crises that urban planning has wrought.
Yeah. Yeah, a lot of it was just, I imagine in the early days, just a free-for-all, right? There was people, especially out in the West, right? The US West, people would just move out there and there was not a whole lot going on. So when a city, just neighborhoods go that way and not quite enough density for a lot of public transit, it makes it challenging. And then they become huge cities, but they're stuck with those consequences, like LA and
Yeah,
others.
exactly. And it's hard to retrofit a city once it's built out because those are people's homes and private properties that you can't just, cut from whole cloth, lay down a new city plan.
Yeah. Are there cities out there that are basically planned from scratch?
Yeah, there are places like Brasilia, the capital of Brazil, was a master planned city in the modernist era, mid-century city planning, where it's designed to look almost like the shape of an airplane for the jet age, a modern city for the jet age.
Amazing.
But there's a wide range of how cities come to be. Some of them are very organic, like you think old medieval cities that just kind of formed over centuries. There are places like LA that built out very rapidly, or like in Chicago, all these straight lines following from these 19th century ideas of rationality and orthogonal street networks. And then there are these master plan cities where, strong central leadership lets you lay it down however you think is best.
I imagine that how the cities are built has a lot to do with the people who helped construct the city, who were there in the early days, how they perceived distance, right? People perceive distance in LA by how far can you go in a car in 20 minutes? The people perceived distance in Stuttgart, how far can you walk? Maybe you can take a horse, potentially, right? And that really probably changes things.
Yeah, one way we talk about that idea of the perception of distance and how the urban form shapes up is this idea of transportation technologies in different eras. And in general, you really see something of a death of geography. That is, if you look at a 1990s suburb of Philadelphia or of Los Angeles, they look very similar to each other. You don't see that sort of local culture. What you see is really building around the transportation technology and design aesthetic of the era, rather than the local hands building the place up. And it's, you know, when cars are how you get around, you build a city it's designed for cars.
Yeah. And then the cars get to be huge SUVs and they still don't fit. All right.
Exactly.
Let's talk. You have this really cool visualization, which I'm going to link to in the show notes, called City Street Orientations Around the World. And it's got some pretty wild graphics. You want to tell people about this and kind of try to describe it for the folks listening?
Yeah. So what these show is the orientation of your city streets. By orientation, we mean on a compass. Like, do they point north, south, east, west? Are they off that north, south, east, west orientation? Or do your streets point more chaotically in all directions around the compass? Like there isn't a more consistent orientation. So to visualize these, I used what's basically just a histogram, but it's a polar histogram. So where a normal histogram will count your observations across some set of bins, for a polar histogram, we've wrapped those bins around the circle of a compass so that each bin represents 10 degrees around the compass. And there's 36 bins total for 360 degrees around the circle. And then the length of each of the bars in those bins represents the frequency of streets pointing in that direction in the city. So in a place like Chicago or Beijing on screen here, most of the streets point north, south, east, west. And what that tells us is it's kind of grid-like. And this is common in a lot of cities around the world. Even a lot of pre-modern cities would still orient themselves generally north, south, east, west, just based on patterns where the sun was rising and setting.
Yeah, I'm super surprised to see, for example, Barcelona is pretty not north south, but it's 90 degrees.
Yeah. Yeah. So in
well.
Barcelona, you see that 19th century and early 20th century Eixample development. So around medieval old Barcelona, Ildefons Cerdà laid out his grand city plan that is fairly grid-like around it. You can really see that here.
Yeah, absolutely. For people listening, some of them look like airplane four-blade propellers, and some look maybe like boat propellers, like really dense. But yeah, it's quite wild to get a quick look. Do we have LA in there? We must, right?
I have LA on the big one. If you scroll down, we have American cities.
Yeah. Okay.
Yeah, there it is.
That's a pretty stark contrast. It's like all of them are propeller looking, other than Boston and interestingly Charlotte. Boston,
yeah, really interesting.
Yeah, but Charlotte doesn't feel like a city like that to me. But what do I know?
Yeah, so Boston is kind of one of those pre-modern, say, American cities, and its street orientation looks like that for a couple of reasons. One, Boston is an agglomeration of multiple smaller towns over several centuries, and each of them had grids to some extent, but they didn't all face the same way. So they all got merged together. And then it has a lot of hills that made it harder to build, especially in the early days. And it really predated America's obsession with grids. Charlotte is kind of the opposite. It's late 20th century, the sort of winding streets and cul-de-sacs to make up those arterial roads, and then these sort of secluded in the center super blocks of subdivisions.
Nice. Well, I'm happy to see that Portland, where I live, is like a perfect propeller blade shape. You know, in our town, you have northeast, northwest, southeast, and then street numbers like northeast 120th Street, right? And it just screams we're on a perpendicular north, south, east, west grid, and it definitely shows up here. And so this is some of the stuff that you came up with OSM-NX?
Yeah, so I used OSM-NX to build all of these street network models from OpenStreetMap data, and then OSM-NX has built into it a visualization module that creates these kind of polar histograms to understand how streets are oriented.
Awesome. Oh, it's super interesting. It's like it communicates to you just immediately as you look at it. It's great. Let's start by talking about OpenStreetMap. This is the backing data, obviously, the important backing data of your library. So what's the origin of OpenStreetMap?
Yeah, so OpenStreetMap started maybe 20 years ago or so. And for folks who haven't seen it before, I often describe it as being akin to Google Maps meets Wikipedia. So it's
Okay.
a
Yeah.
worldwide mapping project with global coverage. Anyone can edit or contribute to it. There is some editorial oversight as well to validate those edits. But what's cool about OpenStreetMap is that its data license allows you to pull data from it. So unlike, say, Google Maps, which is fairly limited in what all it can
Hmm.
draw, you can really pull all of these features from OpenStreetMap. And if you look, if you just zoom in on one of these cities here,
Yeah. Let's
you can
go to
see we have
Riverside. Yeah.
highways, yeah, there's surface streets, rail lines, building footprints, parks, train stations, often grocery stores, restaurants, public schools, all this stuff we're interested in from an urban planning perspective.
Yeah. Oh, it's really interesting, and you can add in additional layers like cycling maps or transportation maps or topological maps, all sorts of interesting things here.
Yeah, exactly. And it really lets you kind of hone in on the specific characteristics of the city that you're interested in. And there's a humanitarian layer that you can see. And this has been one of the big uses of OpenStreetMap now for maybe 15 years or so. Often when there is a disaster in a less developed country, humanitarian aid organizations will go in and use OpenStreetMap and contribute to it to create kind of a digital layer of the facts on the ground. So the Haiti earthquake a few years back was a primary example of that, where it helped them understand where urbanization was, where there were water pumps, toilets, and so forth, the kind of things that people need, but aren't well mapped, often in these informal settlements.
Yeah. Oh, it's amazing. We have, I think everyone was amazed when Google Maps came out, right? Before then we had MapQuest and all those things. You'd have big little up arrow, right arrow to like pull in tiles of the world. And, Google Maps and the worldview that they had. What was that product called? Remember? Where you could kind of fly. It was like a 3D thing. You could kind of fly around in the early days, but it was the same basic data, I think. Anyway, when that stuff came out, it was like, wow, this stuff is, you can now know about the world. You can say, where did that road go? I never went down. You could just follow it and see, or go to Street View or whatever. But a lot of that is locked behind however Google wants you to use it, right? And it's not super accessible. And so having something like this where people can contribute, especially if they care about their neighborhood, right? A lot of this people are contributing back into OpenStreetMap data.
Yeah, exactly. Yeah, so the nice thing with this is that it really is much more in that open source, open data model of the world, which means we can do open science with it, citizen science with it. People, who just notice that stuff is missing in their own community, you're able to fix it. It's no longer that frustration of, well, when will Google get this thing right? Or, hey, we have this new highway that was built outside my town. When's it going to show up? I mean, it's up to you. Like, you can make it show up later today. There is a drawback to that, though. The drawback is you get what we call sampling biases. That is, you tend to see more coverage in places where people tend to contribute more. And those things tend to be correlated with demographic characteristics. Men contribute more than women, higher income places more than lower income places, just from a resourcing perspective. And so one of the challenges we face as researchers using OpenStreetMap data for our analytics work is keeping those in mind, because it's hard to do comparative analysis if you don't know it's because the infrastructure is actually different in two places, or because it's been digitized to a different extent in two places.
Right. Just maybe higher fidelity information might skew some analysis one way or another, right?
That's right, exactly. And it tends to work pretty well comparatively for stuff like roads, streets, whereas things like pedestrian footpaths or fresh food markets might be well digitized in San Francisco and Portland, but probably not, say, in a small town in India or Indonesia, let alone like a suburb of Des Moines, Iowa.
Yeah, absolutely. One of the apps that I use a lot is OnX. Do you know OnX? Familiar? Yeah, OnX is cool. I do a lot of off-road motorcycle riding, and it'll show you all the little trails and stuff, but someone's got to go and enter all that information. And so some places are super well mapped and others are not on the map at all. But yeah, I imagine they probably get some of their data from OpenStreetMap as well, though I haven't been able to tell.
Yeah, it's a good question. A lot of people downstream do use OpenStreetMap data because of its quality and accessibility.
Yeah. Mark out in the audience is asking, is there some kind of mobile app that kind of gives you access to the OpenStreetMap data, kind of like Google Maps?
But there are some mobile apps for it. I don't use them. It has some challenges with routing because it is publicly editable. Sometimes there'll be little breaks in the connections where it's not digitized quite right. But there are routing apps. So you could replace, say, Google Maps on your phone with OpenStreetMap, and you can route with it. It works particularly well in big cities and places like Europe and in the US, less so in small rural areas or in less developed countries.
Yeah. The OnX thing it doesn't really route you, but it shows you on a map and then it shows you where you go on it. And if you choose to stay on the path, then it'll really help you. But it doesn't really say, you can't say, give me directions. At least not when you're off-road. If you're on-road, maybe it'll fall back to something that works. But yeah, amazing. So what's the licensing story behind all this data? Like how the name probably gives a lot of it away, OpenStreetMap, but how is this data usable? What can people do with it?
Yeah, so it's basically usable for non-commercial purposes with attribution. So for example, as researchers, when we are using these data, we just need to attribute where it came from, OpenStreetMap and its contributors. And I ended up including that license information somewhere on the README for OSMNX, because I think a lot of time people will look over these underlying data sources and tools when they're using these kind of downstream tools and apps. So because of that, I just wanted to call out, you can see it on screen here. So I mentioned OpenStreetMap's open data license requires that derivative works provide proper attribution, which is really nice because it's a very easy thing to do for the cornucopia of data that they make available.
Yeah, that's amazing. If I wanted to build a commercial product, I wanted to build OnX Squared or whatever, where I could have people drive around and use that and map it and make notes and maybe contribute back. Do you know what the story? I mean, obviously not a lawyer, right? But would people be able to do that, or is there a paid API, or how does it work?
It's a good question. So I know in practice people can, because I see commercial tools that use OpenStreetMap data all the time. I don't know the details though, because one of the nice things about being in academia is you end up being so divorced from the commercial world that I don't have to worry about that.
Yeah, that's that's pretty good, right? Just do your research, answer interesting questions, and follow the lead, right?
Those are the benefits. Yeah, it comes with drawbacks, but those are the benefits.
Yeah, I'm aware of some of the drawbacks as well, for sure. All right, well, so that is the foundation of this project, OSMNX. Tell us about your project.
Yeah, so OSMNX is a Python package that lets you interact with OpenStreetMap's APIs to make it really easy to download data and build models or a data frame of those data. So the two main things that it does is it can create a graph model. So that is a model of a network like streets or rails or highways or anything else. Or you can create a geodata frame. That's kind of a spatialized version of a pandas data frame using GeoPandas of OpenStreetMap features. So that's all the stuff in OpenStreetMap. It could be points, lines, polygons. It could be traffic signals or parks or schools or roads. But you can download either of those and then do whatever it is you want to do with them. And OSMNX has some other stuff built in. So it has a simple routing engine built in, some visualization tools. You can work with elevation so that you can figure out street grades. It's particularly relevant, for example, if you're a cyclist and you're trying to choose a shortest path that maybe minimizes those grades and so forth.
Even for cars, Google started offering this path uses the least fuel, or in my case, the least electricity, whatever you put into it to make it go. That's also, that's uses like that would be interesting.
Yeah, exactly. Yeah, I mean, kind of superficially, we always imagine that our shortest path to get somewhere is the one that minimizes our travel time. But in reality, there are a lot of other things we try to minimize, including fuel consumption, or for pedestrians. Empirically, we know that people will take longer routes if it's a nicer route. We're not trying to shave off a minute to walk, along the arterial road with the aluminum smelter next to it.
You go through the fence by that old abandoned factory back here, and you can go straight across. It'll be great. You'll save a minute. Like, I'll go the long way.
Exactly.
Amazing. Okay. Yeah, super fun. And as part of those visualizations, can you draw maps? Like, can you?
You can, yeah. So it has some mapping capabilities. You can also plot routes on it. It ties in to Folium package, which is a Python package to develop leaflet JavaScript web maps.
Okay.
So you can do interactive web maps from it. And then on top of OSMNX, there's a cool downstream package called Pretty Maps that I'm not affiliated with, but does really nice, aesthetically pleasing mapping. It's really customizable and really cool.
Mm-hmm. Okay. Do you have a gallery or something?
I do, yeah. So if you scroll up a little bit, there's a link to the examples gallery. It's on GitHub. OSMNX examples.
Oh, if you could pull up different notebooks, huh?
Yeah, exactly. So each notebook kind of covers a different theme of analyses that would be commonly done with OSMNX.
Oh, nice. Yeah, that's really cool. And people can just pull up the notebook and see how it works. What one do you think is a good representative one to maybe like get a sense of how to work with it?
So we count from 0 because we're in the Python world. So notebook 00 is a good place to start. It kind of steps through some of the basic functionality that most users would be interested in starting with.
Sure. Okay. Yeah. So people can download these notebooks in the examples repository, which I'll link to. Yeah, that's really good.
Exactly. So there's a getting started guide in the documentation. And after kind of reading through that, that examples gallery is a really good way to just kind of get a sense of code that you can copy and paste to get started.
Okay, excellent. And 5,000 GitHub stars, almost 1,000 forks. That's quite a bit of traction. Congratulations.
Yeah, thanks. I mean, it's weird. This is very much my my side hustle, but it's also really been a labor of love for a long time now. There is no reward in academia for creating open source packages. I think if you explain it very carefully to academic power brokers, they say, that makes sense, that's great, that's a good contribution. But prima facie, it doesn't mean anything. They have no idea.
It's tough to put it on a tenure application, right?
Yeah, it makes it sound like you're wasting your time and you don't understand what you're supposed to be doing with your time.
But you understand, the research is so easy now.
Yeah. I mean, and that's really how this started. I thought I was going to be able to do this research without having to create my own tool, but it turned out I was not able to.
Interesting. What was your background in programming at that point?
So my undergrad and master's degree, I did computer systems and information systems. I worked in the private sector for a few years and decided to go back to school for my PhD in urban planning. But when I was coming into that, I was pitching myself as this sort of like data science analytics kind of person in that world, which was starting to get kind of hot at that time. So it ended up being a nice fit. And when I started my dissertation, I had this dissertation proposal that was, very, very nice, this kind of big, grand proposal. I ended up only doing the first chapter of it for my entire dissertation because of how these things expand to fill space. Yeah. And when I pitched my proposal to my dissertation committee, there were a lot of assumptions about the tools that were out there. I knew OpenStreetMap was out there. I'd seen there were some tools to download and work with data from it. So I was pretty sure we'd be able to create a nice mathematical graph model of OpenStreetMap data automatically. As I started on my first week of making that happen, I realized the tool did not exist. And in fact, it was profoundly difficult to get data from OpenStreetMap if you wanted to filter it. Like, I just want pedestrian paths, not everything.
Right.
I just want, drivable streets, not everything else. And so the first year of my dissertation work was creating the first version of OSMNX accordingly.
So you must have grants and stuff for your research, as academics do. How much time are you allowed to sort of bring some of that into, adding features back to this project?
Yeah, back to the benefits of academia, the nice thing is, as long as you get what they want to see done, as long as those outputs are there, your time is really completely your own, right?
Yeah.
So you teach a couple classes, you have to publish a few papers a year. Other than that, you're free to do whatever. So I do get grants that help me fund my graduate students. Ironically, it's very hard to get grants to do this kind of open source software, open commons development. Everyone talks about it, and especially grant funders know how much we all use this stuff, and they really like it, but it just doesn't get funded. So what you have to do is you have to kind of hack it in, or sideload it, I guess, into your grants, where the grant will answer this empirical question that's near and dear to the funder's heart. But to do that, we have this tool building phase for 6 months to be able to unlock the analytics for it. And so that's really how a lot of the features and a lot of the modules have been added to OSMNX over time. There's this new project I got to do, so we'll just build it into the package.
Right. We need to be able to answer new questions, so we got to have new ways to get to the data. Yeah.
Yeah, exactly. And it is poorly incentivized in academia, but academia has really been home to a lot of open source tool development, especially niche tools, from stuff like AstroPy for the astronomers and astrophysicists, to things like PySal, the spatial analysis library in Python. But a lot of things that academics have kind of been at the forefront of, but for us, it's always a side hustle.
Right. Stuff with biology, psychology, a lot of the sciences, I imagine.
Yeah.
Working on open source projects like this feels to me very much like the concept of funding basic science, right? Not funding, we need to solve this problem so we can create a bomb or new energy or go to space, but we're just doing it because we need to understand the science better, and it'll help us then apply it eventually, maybe some point, right? Same sort of thing here. Like, if these exist, it will supercharge the urban planning space to a huge degree, but getting people to fund it or to care about it, helping build that up, I imagine it's a little bit frustrating.
No, that's exactly it. I mean, the way I talk about it is, it really is a sort of basic science work that everyone takes for granted, as though these things just exist, right? That this tool just exists. We don't know where it comes from. It has an API. That API just exists. And it really kind of obscures all of these human decisions and social structures and processes and institutions that make it difficult or make other things easy, and really shape what we end up being able to work with.
Yeah, absolutely. Well, someday maybe you can put down, I only wrote 2 papers, but I have 10,000 GitHub stars. So here's your tenure assignment,
This is the future. I'm there for it.
It's a race between whether ChatGPT overtakes all of that stuff, or you get there and people, I don't know, that's a whole different deal. We can talk about that later. Let's talk about the Overpass API, though. That's the way that you get data from OpenStreetMap. What is this?
Yeah, so the Overpass API is another open source tool that lets us query OpenStreetMap's database and download stuff, basically any of OpenStreetMap's features. So what's nice about Overpass is that there are some public instances that you can just query as a web API. You can also host it locally if you want to work around throttling limits, rate limits. Challenge with the Overpass API, you can see a little bit of it here on screen, is that the Overpass QL, its query language, can be really hard to work with to do complex stuff. So this is a fairly simple one. On screen, we can see there's a bounding box with some lat-long coordinates to explain where we want to download data from. The output will be in JSON format. The server timeout is 90 seconds. Big queries can take a long time to run. And then we're querying here for way elements. So way would be a line feature in OpenStreetMap. Any line, it could be street. It could also be the building footprint's boundary line.
I see. Property lines or zoning or whatever, right?
Yeah, exactly. Anything represented as a line. And so we get that back out. It'll be kicked out as a JSON. And what OSMNX does is it works with this Overpass API to try to automate some of these queries. So rather than having to write the query yourself, download the data, and then convert that raw OpenStreetMap data into a useful data format, like drop it into GeoPandas or into a NetworkX graph. It assembles all of that under the hood. It's open source, it's well documented. I have a few peer-reviewed articles about the exact process. So we don't all have to reinvent the wheel trying to work with this data, because none of this is automatic. And in fact, 10 plus years ago, people were very laboriously having to write these long scripts.
You know what I'm going to do? I'm going to get a grad student, and it's going to be their job for the summer to to convert this to Excel or MATLAB for me. Something like that?
Yeah, exactly, yeah. Grad students are great. But what's greater, I think, is having 1 or 2 lines of code to replace your grad student for this.
100%, and let them do meaningful work that they also like, right?
Yeah, that's the
grind
hope.
it out. Yeah, it's fantastic. As I look at this and think about this, it feels to me like OSMNX is a little bit like an ORM is to SQL and databases, right? Like, lets you think more in Python language and concepts, and don't worry about the query syntax and the data and all that kind of stuff. Is that a reasonable analogy?
Yeah, that's a good way to put it. And the goal for doing something like that is to try to democratize doing some of these analyses. OpenStreetMap data are really amazing. Overpass is an amazing resource, but it's really hard to work with unless you have some software development or database experience. And a lot of urban planners or urban geographers or urban sociologists do not. They have great questions. They have great theory. They want to hypothesis test, right? But we limit science if our tools are too difficult to use or the right data are too hard to access.
Yeah. Back to that basic science ideas, right?
Yeah. So for something like this, what OSMNX does is it puts that kind of overpass query into much more natural language. Since Python is so readable in the first place, you can just say something like graph from place, give it a city name, say Pasadena, California. My network type will be drive. And then just like that, I have that drivable street network model within the city limits of Pasadena.
Right. Yeah, that sounds entirely more usable. And one of the things you said is that it can be pretty expensive to query the Overpass API. And so your library caches that stuff locally, right?
That's right. Yeah. So it expensive in the computational sense. All these things are free to use.
Yeah, that's what I mean. Computationally expensive.
Yeah, exactly. And there's a lot of time complexity to it as well. So what we do is we cache everything, which helps you avoid rate limiting. Let's OSMNX be a good neighbor to these free public commons resources that are out there.
Yeah, interesting. It sounds almost like you could have Docker containers for different cities that are preloaded with all the data. That might be interesting to just instantaneously answer a bunch of questions.
Yeah, which is really my workflow. So a lot of what I do will be, I study every street network for every urbanized area in the world, right? So we'll have like 8,000 to 9,000 of these large urban models. And so I'll just have things cached locally. so that the model building and analytics are really at the forefront rather than the downloading and querying for a
Right.
day.
All right. It's not only lets you be a good citizen and not hammer on OpenStreetMap's API, but it just lets your stuff work faster. So the incentives are aligned there, right?
Yeah, and in fact, a lot of the time when people first use OSMNX, you'll download the model of Los Angeles, California, and it takes a minute to run the query on their server, download whatever 100 megabytes of data, and then build that graph theoretic model, do all the spatial stuff to it. But after that, it's nice and fast the next time that you do it because you're able to skip all of that pre-processing.
Right. It probably puts it into some super efficient data structure, trees or a tree or some others, maybe dictionaries, who knows, right?
Yeah, and we use spatial indexes to accelerate all of the spatial queries locally too as well.
Mm-hmm. Is that built into GeoPandas?
Yeah, built into GeoPandas, there is an R tree, which is probably the most common spatial index. But in addition to that, we also use SciPy's KD tree. They have like a C implementation of a K dimensional tree that we use for like nearest neighbor search. So that for example, Google Maps, you say from my origin to my destination, we can do the same kind of thing. Say from this point to that point, we'll snap the nearest neighbor on the network and then solve a path between them.
Okay. So just the k-nearest neighbor algorithm sort of applied to, what is that? The vectors of the intersections or something, and then the distance, the lines.
Normally when you do like origins and destinations, you would snap to a node in the network. So the nodes would be like the intersections and dead ends. And then the edges would be the links, the street segments that connect everything together. Right. And when you solve a path on a graph, it would be from a start node to an end node. And you'd minimize it by something, either the fewest hops or the shortest distance or the shortest travel time. If you incorporate, say, speed limits, everything else, you can bring in congestion information to minimize traffic congested travel time or minimize going up and down hills or anything else.
Excellent. If I got this data downloaded and I wanted to put it into a proper database, and by proper, I mean one that is its own process, different machines can talk to it in parallel and whatever, like Postgres or Mongo or something. Are there good databases that you would recommend or that you've tried, like EdgeDB or Neo4j or Graph databases, the right way to go? Or what do you think?
It depends on what you're trying to do in terms of OpenStreetMap features. So if you're just downloading features and you're not worried about, say, those topological relationships between things, like in a street network, any tabular data structure will do. Any kind of like SQL database will do just fine. For a graph model, you'd want some kind of graph database because they can handle graph algorithms to do stuff like routing, or other kinds of graph analytics, like understanding connectivity on the network.
Yeah. I have this, given this node, tell me all the things that are connected to it. Like that, those kind of questions could be answered.
Yeah, those kind of questions.
Right? Yeah, they're kind of pre-computed by the indices in the structures. What about bringing in other data? What if I have real estate data that doesn't come from OpenStreetMap, but I want to pull that in and overlay it with, say, zoning information overlapped with census data that gives me revenue, how much that person in that area makes per year on average or something like that. Can you answer questions like that?
Yeah, really common use case. So OSMNX can kind of do that by itself, but mostly as a tool in the toolkit to do it. A common way that we often will do this is for accessibility analyses. So for example, here at my house, how many grocery stores could I access within a 15-minute walk? And it gives you a sense of, how car dependent or not a place is. And also we can start looking at food deserts in certain communities where people don't have access to fresh food. So for that, what you're doing is you have a model of the network, and then you also have all of this point of interest data, right? So where all these amenities are located. You would then snap them, load them onto the graph, And then you can calculate accessibility by looking at where those things are located. And you can either look at cumulative opportunities within some time horizon or distance to the nearest opportunity. You can put different decays on it, like the utility of it being so far away drops off with a linear decay the further I have to go, or a non-linear decay if it really drops off fast.
Right.
But
If a
it's
grocery
exactly
store,
that.
if a grocery store is 3 miles away, it's not 1/3 as useful as one that's 1 mile away. It's quite a bit more to
Exactly, yeah.
carry your groceries that far.
And similarly, there's marginal utility for the 30th grocery store that you can reach. Doesn't give you that much benefit over the 29th that you can reach.
Yeah,
Whereas the
that's
first and second are very valuable.
yeah. If it goes from 0 to 1 and 1 to 2, those are big jumps right there.
Yep.
Yeah. Okay. Very interesting. How about some projects that people might be thinking about? You know, they look at this data and they're like, wow, this looks really detailed and neat. And we have all these different aspects we can ask about, but you know, maybe
Yeah.
they just want to play around.
Yeah.
Get-
I mean, hopefully, you know, if you look at the getting started guide or these usage examples, you'll see it's really easy to play around, you know, 2-3 lines of code and you have a visualization of your local street network. A few things that we've done in my lab at USC that may spark some interest. We look at air pollution exposure and driving patterns in Los Angeles to try to understand, you know, who's driving and where, and then in turn, who is exposed to those tailpipe emissions from those cars. So we use OSMNX to model those street networks, to simulate those trips and to look at what census tracts that stuff goes through. We also use it for studies of urban form. So that is kind of the shape, texture, density, the grain of a city. I have this series of square mile visualizations of different cities around the world. And you can really quickly see how different forms of urbanism look relative to each other. So a place like Irvine, California, here in Southern California, has this really coarse-grained street network. A place like Venice in Italy has incredibly fine-grained, like spiderweb street network. Stuff like that really helps to kind of convey these different modes of urbanism and urbanization. We also use these to look at disaster resilience. That is, different street networks will be better if things start going wrong around them. Things with more redundancy, more connectivity built in are easier to route around if parts start failing in a fire, in an earthquake. And so we can calculate some of these characteristics and then make recommendations to planners and policymakers about how to make your street network, how to intervene in it to make it more resilient.
Yeah, in my area, there's an east-west highway, one of them very few that goes from the city west. It has to go through this mountain tunnel, and it's 2 lanes each way in the mountain, or 3 lanes in the mountain tunnel. And there's, even on a Saturday afternoon, there's stopped cars trying to go through that tunnel. And those are on good days. Imagine if there was an emergency, it would just be done.
Yeah, that's the 26, right?
Exactly. It is the 26.
Yeah, I used to live in Portland. I lived
Okay.
I lived in Goose Hollow. And my gym
right
was
there.
in Beaverton, so I would have to go through that tunnel to go work out. And it would always be like, you know, one of these days.
Exactly. Yeah, I live about a mile from Goose Hollow up through that tunnel. So yeah.
Oh, cool.
Yeah. Very cool. Yeah, but there's just, and that one's hard to fix because there's houses all along there. It's a big hill. It's hard to go over it. You know, it would take a lot of willpower to make another tunnel.
Yeah, interesting thing. I did my PhD at Berkeley, and there is another tunnel there that goes from that kind of inner East Bay, Berkeley, Oakland border out to the further east suburbs like Orinda, Moraga, and so forth. And that tunnel is really old. I mean, it's, I don't know, 80 years old, maybe something like that. And they determined that when the big one does eventually hit, it will fail, it will collapse. And it's not, it's cost prohibitive to actually prevent that from happening. So the idea is it will collapse and crush everyone in that tunnel, and they will then build a new tunnel at that point when they have to.
Oh my goodness.
We have that to look forward to.
Yeah, just go quickly when you're in the tunnel. Let's get out of there.
I always did.
Amazing. All right. let's talk real quickly about integrating Open OSMNX with other data science tooling, right? We have so many different things. We have PyTorch, we have pandas, we have polars, all the different things. Like, what are the different integration features? You talked about data frames. That sounds like pandas and GeoPandas, right? So that's one sort of path across those things. But
so OSMNX is built primarily on top of three things. It's NetworkX for the graph models, GeoPandas for the spatial data frames, and Matplotlib for the visualizations. In the spatial Python world, most stuff happens in the Pandas ecosystem, because GeoPandas and PySal and similar tools are very Pandas oriented. I know there's been some work toward geopolars, but it's kind of in its infancy, as far as I know, to this extent. But that'll be great when that's available. NetworkX is another funny one because it's a pure Python implementation, has a lot of loops, and so it can go really slow for calculating some of these big time complexity graph algorithms, things like betweenness centrality, where you have this massive OD matrix, basically all the nodes to all the nodes.
Some combinatorial craziness.
It ends up being very time consuming to calculate those kinds of things for a metro area sized network model. So we'll integrate with other tools. iGraph does that in C. Also using tools like QGraph, where you can do it on the GPU instead. Can be really fast.
Okay. Yeah.
But it's limited because the weighting scheme doesn't let you say, I want to minimize travel time or stuff like that.
I see.
And then also integrated with Folium to create interactive leaflet web maps out of the box.
Yeah. I wonder how the free threaded Python stuff will affect some of those computational things. Like that everything compared with everything else sounds like a so-called embarrassingly parallel sort of problem. Right. And so if you could just say, well, you have 10 cores, so let's just do 10 blocks of them all in parallel, and
so that's what we do when we do it in pure Python. So we'll use multiprocessing generally with all your CPUs. The only challenge is that your OD matrix, your origin destination matrix, is growing at this exponential rate, but then there's a linear number of cores, so going from 1 to 24, dividing by a factor of 24. But when you have, say, 1 million nodes times 1 million nodes in your graph, it's going to take a long time.
It's still going to be slow, but
you've gone from months down to weeks.
Yeah, I mean, you're still dividing it by the number of cores, but it doesn't necessarily mean it's super fast. Although the GPU stuff seems like it could absolutely fly, right?
Yeah, that makes a big difference, and I think that's really the area of growth where handling, basically getting out of Python loops in the first place is the biggest area of growth. And then doing things since these are really just very simple linear algebra problems, being able to do them on a GPU makes it much more efficient.
Yeah. Did you hear about this thing, this new NVIDIA, I don't know what it's called, Project Digits, where they announced a $3,000 desktop AI computer? They call it AI, but really it's just a GPU beast.
That is interesting. No, I hadn't heard about that.
And this thing, it's the size of a Mac Mini. It's this, if you look at the pictures, a little bit of a golden thing. It's kind of clever they made it gold, but that's a massive computer sitting next to you that you could run that. This is pretty interesting, actually, I think.
That is. It's shocking too, because it looks so much smaller than just an NVIDIA card in your desktop.
I think it basically is just the GPU and nothing to do with graphics. And then you just remote into it over, I don't know, a terminal or however or maybe you set it as the Docker host and then you just do Docker locally, but it runs there, that type of thing. I don't know how it works, but I kind of want one.
Yeah. I mean, it looks
So,
sexy enough. Of course, you would want one, right?
of course, but if you had questions like that, if you say I have a million nodes and I could run that on a GPU, getting something like this that's kind of the H100 style of like the really large, just meant for compute, not really a graphics card,
Yeah.
seems like that would really unlock some interesting options.
Yeah, totally. I mean, yeah, so I have a GeForce card in my desktop that I'll pass some of that stuff locally onto, but another one of the academic benefits at USC, we have a high performance computing
Sure. Hmm.
cluster that I can schedule tasks to run on that, say over winter break, and then come back in January and the month of
Yeah,
1,000 CPUs is all done.
that's amazing. We had a mainframe, Silicon Graphics mainframe when I was studying math that we could all work on in this group of maybe 10 of us. And it wasn't as big as what you're saying, but it was, a quite expensive big machine. It had its own room and it was really loud to go into that room. And I remember I came in to do whatever I was working on as a grad student or whatever. I think I was a senior. Anyway, came in to work on my project and nobody could access it. And it was still in there making loud noises like it was running, but it acted like it wasn't running. And so we're like, what is going on? One of the other grad students had run a job like you're talking about, but they were having trouble getting into work because they were math people, not programmers. And they started logging everything. And there were no limits on what people could do to the computer. The people had set it up. And so what had happened is it ran 100% CPU on all the cores all night logging until it ran out of space. And then apparently the computer won't run anymore if it has 0 more bytes. It needed some temp file or something. And so it was just done. I imagine you guys have more guardrails than that.
Yeah, there's a lot of guardrails. I would love to try to do something like that just for the yuck sometime, but we
Yeah,
got to
the admins of that computer were not pleased with that grad student.
I can only
'Cause
imagine.
it took a long time to get it going. It's like a day of work to get it turned back on because they didn't even know what was wrong with it at first. It just wouldn't turn on. Oh well. Jumping back a moment to no, that's not the one I'm going to copy. To the integration. Have you considered working with narwhals?
I looked into narwhals recently. Look, my understanding is one of the things it does well is it kind of abstracts away from pandas versus polars.
Yes,
So you're
exactly.
less tool dependent, right?
Yeah, and it also lets people who want to consume your library, who want to do their work in polars, talk polars to your project, and people want to do pandas, talk pandas, as well as QDF, Modin, Pyro, and other. It kind of is an adapting layer, so people can work in their native framework and then talk to you.
Yeah. I mean, yeah, on paper it sounds great. I haven't played with it yet, other than just being familiar with it. But I mean, that sounds like the ideal, right? We shouldn't be enforcing these certain APIs or languages on people.
Yeah, it does look interesting. I believe its foundational internals are maybe just the API, but they're polars, not pandas, so maybe that's not as good of a fit. But it could be an interesting thing to look in the future to sort of make it native to all the different data frame libraries that people want to talk in.
Yeah, yeah, definitely.
Are you going to need a new grant?
Yeah. Here's the basic science stuff, right? I mean, if I can't get them interested in network models, I don't know about getting into the nuts and bolts of which data frame API we're going to have people use.
Yeah, absolutely. All right. Well, let's close this whole conversation out by talking about something that I know is on a lot of people's minds, and that's LLMs. And what do LLMs mean for this mapping data and the types of questions you can answer and OSMNX, all these types of things? Like, how's that shaping your world?
Yeah, so two ways that I like to think about it. One is what LLMs have to offer us today, and then one is what LLMs have to offer us, say, 5 to 10 years from now. That is, how do we future-proof ourselves, our careers, our livelihoods? And I mean, or just optimistically, how do we really get ahead of it to take advantage of nice things that they'll have to offer?
Mm-hmm.
Today, I am deeply unimpressed with most of the use cases that I see for it. I think that the outputs only look good to people who aren't experts and don't know how wrong it is. does some things well, like having a co-pilot while you're coding and having it recommending. That's nice. I mean, it's like Tab Complete from years ago. It's the same kind of thing, just iterating it. But when someone tells it to, here's the prompt, generate my algorithm for me. Two things. One, it very often doesn't do that good of a job even at this point. And number two, if you don't enjoy doing that kind of thing, I'm not sure why you're in software development in the first place.
I know.
For me, when I interface with it, it's usually in the classroom. And you'll have, people like to complain, kids these days, it's the same way it was when I was in school. A third of the class loves a subject. They're just killing it. They want to be there. They want a job in this. A third of the class, they're like, well, it's a required class. I'll try to do what I can. And a third of them say, I don't know why I'm here. Why is this a required course? I hate this. Is there any way I can cheat to just get a passing grade?
Where's my shortcut?
Exactly. I mean, and the difference today is that LLMs make it so much easier, and they really normalized cheating as well, where we don't have that good of systems in place to be able to detect it for code, for writing, for anything. And I think one of the problems here, it goes back to like licensing or attribution. When we normalize this kind of cheating, we're normalizing taking credit for things that aren't our work. And if we're doing that in school, we build those habits. What's it going to look like when we're working in the workforce? We either don't have the skills that people think we have, or we think it's just normal, acceptable practice to copy and paste and say, here's my intellectual contribution.
It's too much of a crutch. And if, maybe it solves 90% of the problems, but that 10% it doesn't, you're fully incapable of approaching that problem, right?
Exactly. Yeah. And I think, so if that's the first part, what LLMs offer us today, I think the second part is, say, 5 to 10 years from now. And part of it is scary and part of it is exciting. I think that coding, as it looks today, is going to largely go away over my lifetime, because coding is this mix of art and intellectual labor and manual labor. The manual labor parts, will be going away, and that's where a lot of people use LLMs now to reduce some of that grind of coding. And I think it's important for us to figure out where those intellectual contributions are, where the art, the poetry of coding remains a human contribution moving forward, where we have, that sort of human in the loop to make ethical decisions that we don't pass off. Where it is humans who are doing some of the architecting and not just handing it off saying, here's a prompt, now redesign our financial system from the ground up for us, but that it remains human guardrails and human ethics and human notions of justice, that we use AI to help us, but doesn't replace that.
Yeah. I feel like there's going to be a lot of people who are programmers now are going to have to kind of be a senior tech team lead type of thing, where the team is asking the LLM to do stuff for you. And that's going to be awesome for those people, us. But for the people who are brand new, there's going to be a wider gap to try to cross. So it's going to be harder and harder to go from real beginner to that level when who's going to employ you when it takes you a day and I can ask the LLM to do it in 5 minutes and I got to review it either way. That's a very concerning social consequence, I think.
No, exactly. And I think those kind of entry level jobs are very much more labor focused, right? The senior dev isn't doing that work because someone with less experience, less pay can do it. And if LLMs replace that over time, it's really hard to get your foot in the door in that industry.
Yeah. It's going to be like COBOL programmers did not know how to program without an LLM someday.
Yeah.
I don't know if that's good or bad, but it's going to be weird. Anyway, I think it's probably a pretty interesting, and given access with your API and with all this data, I'm sure people will be able to ask and answer interesting questions with it.
That's the hope.
Indeed. All right. 2 really quick things to close out our conversation. Roadmap. Anything on the roadmap coming real soon that people have been asking about, thinking about?
Yeah, so I just released V 2.0 a month or so ago, and so thank you. And that was really just a year of rethinking the API. I was going to allow myself breaking changes, really cleaning things up. I added type annotations for the first time. I really changed the linting and formatting, CI, pre-commit, everything. So it's a much more rigorous package at this point. I'm taking a breather right now, where I don't have that much big on the horizon. I try to keep a really clean issue board as well, where I quickly triage. This is in scope, this is not. And
I noticed you have 3 open issues and 0 PRs, which is awesome.
Yeah, I try to do it courteously, where I'll tell people a lot of the time, this isn't in scope for the project, but I appreciate the suggestion. But I'm busy, so keeping a clean issue board makes my life simple. So short answer, I'm taking a breather instead of road mapping in
But
January.
you just had a big release, which is cool.
Yeah.
Contributions accepted?
Absolutely, and very often what I ask when someone opens an issue and I say, that does sound useful. Would you like to open a PR? And as much as this is my side hustle, most of the pull requests that I add to it are very much aligned with a current or recent research project that I'm working on.
Right.
So for others, if you see a gap or a cool feature that could make people's lives easier, better analytics down the road, please propose it, and I'd love a contribution.
Excellent. All right, final call to action. People are psyched about mapping. They want to get started. What do you tell them?
I tell them to work through existing examples from the tools that are out there. If you haven't done any kind of mapping before, there's a lot of cool packages in R and in Python. Find something you're comfortable with, work through some tutorials, and then figure out something close to home. It's so much easier if you have that kind of local motivation, local knowledge. Do some mapping, do an analysis in your community for something that's bothering you that you think could be better.
Excellent. All right. Well, thank you for being here, and congrats on the cool project.
Thank you very much.
Yep. Bye.